8814. The pole pieces or shoes used in a DC generator are part of the A. Armature assembly, B. Field assembly, C. Brush assembly. The correct answer is B. In a DC generator, the field assembly consists of the field poles or shoes, which are responsible for generating the magnetic field. The field assembly is typically stationary and houses the field winding, which is excited with direct current to produce the magnetic field required for generator operation. The pole pieces or shoes are attached to the field assembly and are strategically positioned around the armature assembly. They help establish a magnetic field that interacts with the armature winding, inducing voltage as the armature rotates within the generator. The field assembly, including the pole pieces or shoes, plays a crucial role in creating and maintaining the magnetic field in a DC generator. They are not part of the armature assembly or the brush assembly, which have different functions within the generator system. Therefore, the pole pieces or shoes used in a DC generator are specifically associated with the field assembly. 8815. How many cycles of AC voltage are produced in a 6-pole alternator of the revolving field type for each revolution of the rotor? A. 4, B. 3, C. 6. The correct answer is B. For every revolution of the rotor in a 6-pole alternator, 3 cycles of alternating current are generated. This is achieved because each pair of poles within the alternator produces 1 complete cycle of AC. Therefore, as the rotor completes 1 full revolution, the alternator generates 3 cycles of alternating current, contributing to the overall electrical output of the system. 8816. If the reverse current cutout relay contact points fail to open after the generator output has dropped below battery potential, what happens to the current flow in the generator armature and shunt field? A. Current flows in the normal direction through the armature and in the opposite direction through the shunt field. B. Current flows in the opposite direction through the armature and in the opposite direction through the shunt field. C. Current flows in the normal direction through the armature and in the normal direction through the shunt field. The correct answer is C. In the event of a failure of the reverse current cutout relay contacts to open when the generator output falls below the battery potential, a reverse flow of current occurs. This means that current will flow from the battery through the armature in the opposite direction of its normal flow. However, it's important to note that the current will still flow through the shunt field, but in the normal direction of flow through the field coils. This situation results in an abnormal current path within the electrical system, potentially leading to issues and imbalances. 8817. How does a magnetic brake used to stop rotation of an electric motor armature operate? A. A friction brake is applied by a magnet and released by a spring. B. A friction brake is applied by a spring and released by a magnet. C. Centrifugal force releases a rotating brake cog from a stationary notch when the armature reaches a certain speed, and magnetic force re-engages the cog when the electrical power is turned off. The correct answer is C. In this scenario, the magnetic brake incorporates a mechanism that relies on both centrifugal force and magnetic force to control the braking action. When the motor is powered on and the armature starts rotating, centrifugal force comes into play as the armature reaches a specific speed. The centrifugal force causes a rotating brake cog to disengage or release from a stationary notch or stop, allowing the armature to continue rotating freely. When the electrical power to the motor is turned off, the magnetic force comes into play. The magnetic brake applies a magnetic field that attracts the brake cog back into engagement with the stationary notch or stop. This magnetic force resists the rotation of the armature and brings it to a stop. The combination of centrifugal force and magnetic force allows for controlled braking of the motor armature. As the armature reaches a certain speed, the centrifugal force releases the brake, and when the power is turned off, the magnetic force applies the brake to stop the rotation. 8818. In a generator, What eliminates any possible sparking to the brush guides caused by the movement of the brushes within the holder? A. The brush pigtail. B. Brush spring tension. C. Undercutting the mica on the commutator. The correct answer is A. The brush pigtail is a flexible wire or conductor that connects the brush to the terminal or holder within the generator. It serves as a flexible connection that allows the brush to move freely within the holder while maintaining electrical contact. As the generator operates, the brushes move or slide along the commutator, which can create friction and generate sparks. The brush pigtail is designed to absorb any movement or vibration of the brush within the holder, reducing the likelihood of sparking. It provides flexibility and a stable electrical connection between the brush and the generator circuit.